space in front of the first one, and there's always space after the second one to show my work. So then in the first one, this is technically in brackets as a single factor. It doesn't simplify with anything on the bottom. This is connected together because of subtraction as a single factor. It doesn't cancel with anything on the bottom. And of course, because I'm adding in between, I'm not able to cancel anything if there was something in the first fraction with the second fraction. Because we can only simplify or cancel if we're multiplying. And in this case, we're adding. And so we need to think of our fraction rules. What do we do when we're adding? We need a common denominator. Now, often people just say, oh, if this one has an 8, I'll multiply this one by 8. And if this one has a 6, I'll multiply this one by 6. And that will give a common denominator of 48. But sometimes you have to be careful because there's a smaller one. And it's not wrong if you do 48, but you will have work in the end. Okay? So first, I'll show you the best way. And then I'll show you, what if I didn't see that? What if I did the other way? What would happen? How do I deal with it? And it's not wrong. It's just a little bit more work. So with 8 and 6 in your times table, do you see that 24 is the lowest common denominator, not 48? You can get 24 by multiplying the 8 by 3 and the 6 by 4. Then when I look at variables, one has an x squared, one has an x, so the first one needs an x, and the second one doesn't. And it's also very helpful that I put brackets around my x plus 5 and brackets around my x minus 7. Because I now have a common denominator of 24x squared and 24x squared. But when I multiply the 3x to the top, that 3x gets multiplied by that whole thing on the top, and we do have to distribute here, and we're going to have to distribute here. So when I distribute, I get 3x squared plus 15x. And when I distribute here, I'm going to get 4x minus 28. And again, that would be grouped as a single factor. If you were thinking about simplifying the x squared, you cannot, because that on top gets connected as one big thing. So how do we add fractions once we have that common denominator? Once we have that common denominator, all going to be over 24x squared. And do I have any like terms? I do. I'm going to have 3x squared. The 15x plus the 4x will be plus 19x minus 28. And again, this is all grouped together now as one huge factor. The only way you could simplify it with the bottom is if you could either pull out a common factor with the numbers, but there's nothing in 3, 19, and 28. And if there was a common factor of x, you could pull that out, but you can't because there's no x's in the 28. So this is finished. And of course, they list that x can't equal 0 because that would make you divide by 0. Now, what would happen if you did, I'm going to do it again, x plus 5, because can you see yourself, x minus 7, here's our original question, can you see yourself sort of just deciding to times by 6 and times by 8 to get a common denominator? Because you're like, well, that's easy. If I know 1's 6, 1's 8, I multiply 1 by 8, 1 by 6. That seems easy. It's not the lowest common denominator. It's not wrong, but I'm going to show you why it's a little bit more work. Okay? And you might be like, ooh, it's worth thinking at the beginning to see the 24 rather than the 48. I'm going to multiply top and bottom by 6. Again, these are grouped together. It's going to be important. This one still needs an x and an x. And now I have a common denominator of 48x squared and 48x squared. And if I distribute this, I'm going to get 6x squared plus 30x. And if I distribute this, I'm going to get 8x minus 56. And again, this would still be grouped as one factor, one factor. 48x squared here. Do I have like terms? Yes, I'm going to have 6x squared plus 38x minus 56. And again, this is still grouped as one big thing. But where we were done on the one on the left, because there was nothing that could be factored, notice on the one on the right that in the top there's a common factor of 2. And I could pull that out. And then, since I'm multiplying right there, I'm allowed to simplify. And I can simplify the numbers. The 2 and the 48 would reduce to 1 and 24. So we do, in the end, get the same answer. However, we have 2 extra lines of work because we didn't see the lowest common denominator right away. It's not wrong, but on the right, if you had stopped at the same place, you would lose marks for not simplifying completely. Or when you check your work at the back, you'd be like, why is my answer different than the answer in the back? Your answer isn't simplified yet. Okay? And this is going to happen to you. It's good if it happens to you because it means that you're practicing and you're checking your answers at the back of the book. Right? You don't want this to happen to you just on quizzes and tests. You want to make sure that it happens to you early when you're doing practice, because that's how you're going to train yourself to see some of these ideas that help you simplify it earlier. Okay, that was just part A in 2 different ways. Part B, things get more difficult when you're subtracting, and in part B we're subtracting 3c minus 2 over 3cd, subtract c plus 8 over 5c squared d. Okay. So again, we're subtracting. This is adding and subtracting, so those things would get grouped together on the top and the bottom. And we look at our numbers. Lowest common denominator between 3 and 5, we would have to multiply this one by 5 and this one by 3. So top and bottom. Looking at your variables, this one's missing the c. This one has all of our variables. And again, with things on top like this, those brackets are important because we're going to have to excuse me, distribute. So we have our common denominator. Now, this is going to be a 15c squared d, and this one is a 15c squared d. And here we have 15c squared minus 10c, and here we're going to have 3c plus 4. So we have a common denominator of 15c squared d. Then if students are going to make a mistake, they're going to make the following mistake. So I'm going to first write the top wrong in red. And I'm going to do the mistake that you guys are going to do. So most of you will look at it and say, I don't see what he did wrong. So you're going to have to look deep into what just happened. Okay? So in red, I'm now going to subtract here to get my like terms. I have 15c squared. I'm going to, these are like terms, so minus 10c minus 3c would be minus 13c, and then we have the 24. And this is wrong. You see what's wrong? Wait. That's great. But if you don't see what's wrong, look at it. See if you can figure out, double check my math. It's just something wrong in the top. Because I think I did exactly the same thing I did in part A. Why did I make a mistake in part B? You think you see it?
Does it have to do with...
Don't say it out loud. We're letting everybody, I want everybody to formulate an opinion, right? And if you have no opinion, you will make this mistake. That's the scary part, right? Are you ready to see the right answer? And you can determine in your head, you could like do a little fist pump if you saw what it was, okay? Now, it might have been helpful if I kept brackets around these things. Because what we're doing here is we have one fraction subtract another fraction, which means we're subtracting that whole fraction. We're not just subtracting part of it. And this negative sign goes to the 3, so you're also subtracting the 24. So if I go to correct this, the 15c squared was right. The minus 10c minus the 13c minus 3c to get minus 13c was right. But I also, and you remember this from subtracting the regular polynomials from grade 9, that negative gets distributed, it's going to be a minus 24, not a plus 24. Right? So if you saw that, you can give yourself a little fist pump. But anytime you're subtracting, you've got to be really careful. Subtracting is harder than adding. You didn't have to worry about that with adding because adding didn't matter. But with the subtracting, it does. And again, at the bottom there, they say that C can't equal 0 and D can't equal 0. Okay, questions for practice on this one, and now I'll give you some time to try some of these. There are 6, 7, and